Here is a pod that is perfectly healthy, doing real work, and completely silent as far as Kubernetes is concerned. kubectl logs returns nothing at all. Today's CKA task is to fix that without rewriting the application. Add a second container alongside it that streams the app's log file to standard output, and share a volume between the two so it can actually read that file. This is the streaming sidecar pattern, and it is one of the most quietly useful things on the exam. Let's run it on a live cluster. Here is the setup. A legacy application has been packaged into a deployment called report engine in the legacy namespace. It writes everything it does to a log file inside its container and prints nothing to standard output, so it is invisible to the cluster's logging architecture. 3 things are asked of you. Add a second co-located container to the same pod, named logstream, using the busybox image, whose command streams that log file to standard output. Give both containers a shared volume so the file is visible to the new container, and change nothing else about the container that is already there. One fact explains this whole question. Kubernetes has a single logging path. The kubelet captures what a container writes to standard output and standard error, and kubectl logs replays that. It does not know about files, it does not look inside your container's file system, and there is no configuration to point it at one. So an app that appends to a log file is not badly configured, it is simply outside the pipeline. The documented fix is a streaming sidecar. Put a second container in the same pod whose only job is to tail that file and echo it to its own standard output, where the pipeline picks it up. That works because containers in a pod can share volumes. Mount one volume, and emptyDir is plenty, into both containers at the directory holding the log file. Let's see the problem before fixing it. The deployment is running. One pod, ready 1 of 1, no restarts. Nothing is broken. Now ask for its logs, and look carefully. There is no output, not an error, not a warning, just nothing, which is the most confusing failure mode there is. The app is definitely producing output though. Exec into the container and tail the file it writes, and there are the log lines, timestamped, several of them, sitting in the container's own file system, where kubectl cannot reach them. Now the edit. In the exam you would run kubectl edit on the deployment, or dump it to a file, change it, and reapply. Both are fine. 3 things go in. A volumeMount on the existing container, pointing at the directory that holds the log file. A second container, named logstream, image busybox, whose command tails that same file, plus the identical volumeMount. And the volume itself, an emptyDir, which sits at the pod spec level next to containers, not inside them. Watch the indentation there, because that is where this question is usually lost. Notice what did not change. The app container keeps its image and its command exactly as they were. Apply it. Changing the pod template starts a rolling update, so the deployment builds a replacement pod with both containers and retires the old one. Wait for rollout status to report success, and then look at the pod list. The ready column now says 2 of 2. 2 containers in a single pod, both running, sharing a network namespace, and more importantly for us, sharing a volume. 1 pod, not 2, and that distinction is the whole point of a sidecar. And here is the payoff. Ask for the logs again, this time naming the container with -c logstream, and the app's log file comes streaming out of kubectl. Same lines, same timestamps we saw hiding in that file a minute ago, except now they are flowing through the cluster's normal logging path, which means anything that collects logs from this cluster picks them up too. The application was never touched. Note the -c. Once a pod has more than one container, kubectl needs to know which one you mean. It is worth proving that this really is one shared volume, and not a coincidence. Exec into the sidecar, the second container, and list the log file. It is right there, owned by root, growing, even though a completely different container is the one writing to it. Then read the mounts back from the deployment. Both containers mount the same volume named logs at the same path. That is the mechanism in 2 lines of output. Same volume, same mount path, 2 processes, 1 file. Last check, and it is the 1 part 3 grades. read the original container back. Same name, same image, same command it started with. The only thing that changed about it is the volumeMount it needed to share the file, which the task explicitly allows. And the volume itself is a plain emptyDir, created with the pod and thrown away with it, which is exactly right for a log relay. No persistent volume claim, no storage class, nothing to provision. Things to carry into the exam. The volumeMount goes in every container that needs the file, and there are 2 of them. Forgetting the app container is the classic mistake, because then the sidecar tails a file that will never appear. The volume itself lives at the pod spec level, beside containers, not inside one. An empty emptyDir written as name plus emptyDir with empty braces is all you need. Search the docs page for emptyDir and copy the shape. Mount at the directory, not the file. Once the pod has 2 containers, kubectl logs and kubectl exec both need -c to say which one. And one modern footnote, Kubernetes does have native sidecars now, an init container with a restart policy of always, but a question that says co-located container in the same pod means a plain second entry under containers. To recap, kubectl logs was empty because the app writes to a file, and the kubelet only ever captures standard output. We added a second container to the same pod, logstream on busybox, tailing that file to its own standard output, and an emptyDir volume mounted at the log directory in both containers so the file is visible to it. The rollout took the pod to 2 of 2. kubectl logs with -c now streams the application's output. Both containers demonstrably share one volume, and the original container kept its image and its command. A sidecar does not fix the app. It translates it into something the platform can already see. Subscribe for the rest of the CKA series, and the full write-up is on dev.to.